Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of various driving situations to continually develop automotive technology. Today I'll introduce you to the business division Gasoline Systems. At the heart of our work is the generation of engine power and the transfer of power via the transmission to the wheels. Our know-how encompasses the entire drivetrain of an automobile. That includes the fuel supply, intake air management, the fuel injection, and ignition. In addition, the whole of engine management, transmission control, and finally, exhaust gas aftertreatment. Gasoline systems expertise can be applied to gasoline engines with manifold or direct fuel injection, as well as to flex fuel and electrified engines. Our engineers work together with automobile manufacturers to develop solutions for new performance standards and technology. We apply our systems in the vehicle, developing them through to serial production. So let's have a look and see just where in a vehicle our know-how can be found. Let's use a gasoline direct fuel injection model to follow the path the fuel takes from the tank to ignition. The in-tank unit is a modular system that delivers the fuel from the tank to the high-pressure engine pump. It requires only minor modifications to be adapted to any vehicle. Now let's take a closer look. Our fuel filters allow no particles larger than 0.005 of a millimeter to pass. Not even a strand of my hair would get through. Unless, of course, I modify myself. Within the system, the high-pressure pump increases the delivery pressure created by the tank unit many times over, raising it in some cases to 20 megapascal or 200 bar, and that means serious power. The fuel rail distributes the fuel to the high-pressure injection valves. These injectors with multi-orifice technology enable high precision, the tiniest fuel droplets, and a variable spray configuration for optimal combustion to be achieved. But in addition to fuel, an engine also needs air for combustion. With our products, we offer comprehensive intake air management. Let's take a detailed look at the individual components. You'll find our throttle device here at the entrance to the manifold. To reduce the smallest adjustable airflow setting still further, we've optimized the geometry of the throttle. Whoa, that's a major draft in there. With its special geometry, the manifold influences the charge cycle processes, which give the engine its respective performance characteristics. Let's accompany the air on its way to the combustion chamber. Here we find the swirl control valves. They influence the passage of air into the combustion chamber and create a targeted swirl effect for the best possible combustion. Wow, that's fun! Oh, excuse me. The air supply is a significant determining factor for the quality of combustion. The air mass must correspond to the fuel mass. Its movement must be coordinated with the form of the stream of injected fuel to ensure the ideal spread of the flame front in the combustion chamber. The mixture formation is an important factor for exhaust gas treatment in the catalytic converter. With the help of the lambda sensor, it's regulated to enable the three-way catalytic converter to achieve its maximum treatment performance. Driving pleasure with low emissions. You've just seen systems that make a contribution to economical and clean combustion. They provide the exact dosage, processing, and distribution of air and fuel for each individual combustion cycle, and of course exhaust gas aftertreatment. All of which is regulated by our engine control unit. Let's take a closer look at the unassuming little box. We're here in the computer center, headquarters of engine management. I'll demonstrate its performance capability using the example of direct start. with which a fuel-saving stop-start function can be realized. Our engine control unit, here the DI-Motronic, detects when the vehicle has come to a halt and cuts off the engine. A speed sensor constantly measures the crankshaft angle and transmits the data to the control unit. Based on this angle, the DI-Motronic discerns the shut-off position of the individual cylinders. It selects the one suitable for the direct start and calculates the actions necessary for the direct start. As soon as the driver wishes to move off, DI-Motronic instructs the starter and the fuel injection system. Fuel is injected. Ignition. The engine starts. Turbocharged engines with gasoline direct fuel injection let the DI-Motronic show its full performance capability. The interplay of fuel injection, exhaust gas turbocharging, and camshaft timing control or scavenging calls for high-performance engine management. The investment pays off. The once typical disadvantages, such as higher peak consumption and turbo lag, are history. That makes driving a lot more fun. Just generating the power isn't enough. It must also be efficiently distributed to the wheels. In our business unit's continuously variable transmission and transmission control, we develop components, modules, and software to ensure optimal delivery of the power to the roads. Continuously variable transmissions have significant advantages for urban traffic: no gear shifting and coupling, more driving comfort, and lower fuel consumption, thus less CO2 output. Automatic transmissions can be adapted with software to meet a wide variety of demands. Our electronic transmission control recognizes the current gear status, the driving situation and style, and reacts accordingly, for example, with optimized shifting points. And that means more driving dynamics and comfort. Bosch Gasoline Systems helps automobile manufacturers worldwide to further improve the functions of the entire engine system for higher performance, lower emissions, and reduced consumption with correspondingly less CO2 output. We develop our market-driven, customer-specific engine management systems in development centers around the world. Electrified engines will play an increasingly important role in the future. Our engineers have worked successfully for many years on the integration of the combustion engine and the electric drive. Our ambition is to keep on making vehicles better so that you can be a cleaner, more economical driver and more at ease on the road. We achieve this ambition with a comprehensive program for the entire drivetrain, drawing on a wealth of know-how to serve our customers with the greatest competence and individual care. With our services, we help automobile manufacturers to adapt systems individually to their vehicles. Together, we always find the right solution.
Bosch, invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of a wide range of driving situations to continually advance Bosch automotive technology. Today we're looking at vehicle safety. Most car accidents fall into three categories: skidding out of control, rear-end collisions, and crashes in which the vehicle rolls over. We're developing new functions to minimize the risk of such crashes and to provide passengers the best possible protection should an accident occur. Our goal, all-around safety with CAPS. Combined active and passive safety. CAPS is an intelligent modular vehicle safety system that employs new advanced safety functions to protect the driver in critical driving situations. These new functions are the result of connecting existing safety and comfort systems together in a network. One such network system is the Electronic Stability Program, or ESP. It uses active brake intervention to prevent the vehicle from going into a skid. Adaptive Cruise Control, or ACC, is a comfort function. It regulates vehicle cruising speeds and, on freeways and secondary roads, automatically maintains a safe distance to the vehicle ahead. In order to realize more advanced safety systems, we've installed a video camera as an additional measurement feature right next to the radar sensor. Our high-performance video system is multifunctional, scalable, and has benefits both day and night. A fourth example is the airbag control unit. In the event of a crash, it deploys the airbags and adjusts seatbelt tension to provide passengers the best possible protection against injury. CAPS connects these and other high-performance components and systems together in an information network. This makes data available for multiple uses at various sites, giving us an important information head start in improving vehicle safety. Let's take a look at some examples of how CAPS is connecting these systems together to create an entirely new network of safety functions. Proactive response to anticipated danger. That's the job of a group of CAPS functions called predictive safety systems. These are the result of networking the radar-based ACC function as well as active safety systems such as ESP. PSS takes a three-stage approach to vehicle safety. Predictive brake assist recognizes dangerous driving situations with a high probability of emergency braking and prepares the brake system for a panic stop. When the driver suddenly applies the brakes, maximum braking force can be reached in the shortest possible time, reducing the distance it takes to come to a halt, preventing collision or at least decreasing the force of impact. Predictive collision warning extends the scope of this function to include a warning to the driver, such as a jolt of the brakes. In the near future, even emergency braking will be able to be triggered automatically when a collision becomes inevitable. Let's move on to another example. The CAPS function Early Pole Crash Detection combines the airbag system and ESP. When an extreme sideways movement of the vehicle is detected by ESP, the airbag control unit is immediately alerted to the possibility of a side impact. If the collision actually does occur, the side and head area airbags are deployed much earlier than before, significantly improving the protection they provide. CAPS advanced rollover sensing helps in the event of vehicle rollover. Many crashes throughout the world involve vehicle rollover. In the United States, for example, rollovers are responsible for about 20% of car accidents involving fatalities. In addition to data from the rollover sensor in the airbag control unit, advanced rollover sensing uses data from ESP. The ESP system detects critical sideways motion of the vehicle before it goes into rollover. The rollover sensor within the airbag control unit detects the rollover movement of the vehicle. When this information comes together, the critical driving situation can be detected sooner. The result is a head start in detecting this dangerous crash. This allows the seatbelt to be tightened as well as side and head airbags to be deployed earlier and more precisely, providing passengers with the best possible protection. Secondary collision mitigation, or SCM for short, is another CAPS function. In many accidents, vehicles become involved in a series of several collisions, like here on the freeway, for example. A rear-end collision like this can happen at any time. In the shock of the frightening first seconds after initial impact, the driver can easily become disoriented and lose control of the vehicle. When this happens, it's very possible that a second, more critical crash will occur. But that doesn't have to be the case. The SCM function uses data from the airbag and the ESP system. If, as in this case, a crash does occur, it's detected by the airbag control unit. Using vehicle crash information, it calculates the strength and direction of impact and activates, where appropriate, the restraint systems. If the crash is severe enough, SCM rapidly passes this information on to the ESP control unit. To prevent further collisions from occurring, braking action is triggered automatically. The vehicle is slowed down. Here you see the result. Secondary collision mitigation from Bosch slows the vehicle, dissipating as much energy as possible so that it comes to a stop quickly after a crash. helping to prevent successive collisions, or at least to reduce their severity. What you've just seen is only a glimpse of the many possibilities for creating new CAPS functions with innovative combinations of existing safety and comfort systems. The sum total of these new functions is maximum vehicle safety for all passengers on board. CAPS, Combined Active and Passive Safety from Bosch.
Bosch. Invented for life.
In today's heavy traffic, driving is hard work. The driver needs to concentrate at all times, respond quickly to new situations, and react by braking or accelerating. With Bosch Adaptive Cruise Control, or ACC for short, driving is far more relaxed. The predictive system takes pressure off the driver. ACC controls the speed of the vehicle, maintaining the driver's selected distance to the preceding vehicle. When the vehicle gets too close to the car ahead, the system slightly releases the accelerator or gently applies the brakes. This isn't just convenient for the driver, it also enables him or her to concentrate better on the traffic situation. ACC is easy to operate. The driver selects the desired speed on the control unit and sets the safety distance to the preceding vehicle. The safety distance can be set at several levels, adapting to the driving situation and individual driving style. ACC is now active. A long-range radar sensor now monitors the driving situation in front of the vehicle. Using the reflected signals, ACC calculates the distance, direction, and relative speed of the vehicle ahead, even when the road doesn't follow a straight course. When the road ahead is clear, ACC maintains the set desired speed. If the driver approaches a vehicle on the road or another vehicle cuts in front of it in the same lane, ACC responds automatically. The system interacts with the engine control or the braking system in conjunction with the electronic stability program ESP and ensures that the set safety distance is maintained. Once the road ahead is clear, the vehicle automatically accelerates to the desired preset speed. ACC allows harmonious traffic flow on the roads. But the wishes of the driver are always given top priority. Even when ACC is activated, the driver can always accelerate or brake at any time. The standard ACC can be activated at speeds of approximately 30 km per hour upwards and supports the driver, particularly on cross-country journeys or on the motorway, up to speeds of around 200 km per hour. The ACC stop-and-go version is also active at speeds under 30 km per hour down to vehicle standstill. The system maintains the safety distance even at low speeds and brakes automatically in stop-and-go traffic right down to vehicle standstill. If the vehicle ahead moves forward within 3 seconds, the ACC vehicle follows automatically. If the vehicle remains stopped for longer than 3 seconds, the driver simply needs to reactivate the system, for example by briefly stepping on the gas pedal to return to ACC mode. ACC Stop and Go thus supports the driver in extremely heavy traffic and traffic jams. Both ACC versions from Bosch work economically with just one radar sensor. The tried and tested ACC functions can be further optimized via intelligent networking with environment sensors already installed in the vehicle, or by integrating additional sensors such as a video camera or other short or long-range radar sensors. This enables the ACC speed range to be extended from 200 to 250 km per hour, or offers increased dynamics when driving off from a standstill position. The ACC sensor control unit is also a key component for implementing predictive safety functions that enable a faster reaction to dangerous situations. Adaptive cruise control from Bosch. Safe and comfortable driving.
Bosch. Invented for life.
Insufficient lighting and backlight at night are frequent causes of road accidents. With conventional low beams, the range of vision is approximately 40 meters. Obstructions and dangers are therefore often not recognized in time, especially when they're not illuminated or are poorly lit. High beams light up the road for a distance of up to 150 meters, but also blind oncoming traffic. This means they can only be used approximately 15% of the driving time. Studies show that the risk of a severe accident is twice as high at night than during the day. Night vision, the active infrared night vision system from Bosch, turns night into day. With night vision, the driver sees approximately 3 times further than is possible with conventional low-beam lights, without blinding oncoming traffic. The driver can identify the course of the road, other road users, obstructions, or roadway markings up to 150 meters ahead. This makes driving at night much safer. Night vision captures all objects in the field of vision and offers the driver a true-to-life image of the road ahead. The function makes it easier to see not only other road users, but also inanimate, unlit objects such as traffic signs, lane markings and borders, or obstructions on and next to the road. 2 infrared headlamps illuminate the road with light beams that are invisible to the human eye. A video camera behind the windshield records the scene on the road. Via an electronic control unit, the image data is passed on to a display in the instrument cluster or the central display. The display shows the driver a clear black and white image of the driving scene. Night Vision Plus is an advanced version of the established night vision system and offers additional support in identifying humans at night. When the system identifies a pedestrian or cyclist within a range of around 25 to 90 meters in front of the vehicle, they are highlighted clearly in the night vision system. The Night Vision Plus intelligent image processing enables precise identification of humans as a clear image in the display screen. The active night vision system searches for typical human characteristics in the flow of image data. This allows pedestrians and cyclists to be differentiated from other objects in the scene. Accident statistics show over half of accidents on the road in Europe resulting in the death of a pedestrian happen at night. Night Vision Plus directs the attention of the driver to potentially endangered road users such as pedestrians and cyclists. The driver is given more reaction time and can avoid possible accidents. The infrared night vision system from Bosch makes driving in the dark much safer and more comfortable. Night vision from Bosch, contributing to increased safety and comfort on the road.
Bosch. Invented for life.